Hi, good to see you again. Welcome to Block 1, Constructing, Measuring, and Using Geometric Notation. Lesson 7. I'll share my screen. So, in your previous lesson, you learned how to draw angles up to 180 degrees. In today's lesson, you're going to learn how to draw and measure angles between 180 degrees and 360 degrees. You're going to need the equipment that you used in your previous lesson. So get your protractor, your ruler, and your pencil so that you can really have a good practice in this lesson. Remember to like the video, share the video with those you think can benefit, subscribe to the channel, and click on the notification bell so that when new videos are released, you will be notified. Thank you. Before we get started, I would like you to pause the video and answer the retrieval practice questions in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So, what is the sum of angles at a point? Angles at a point sum to 360 degrees. How many degrees are equal to half a turn? Half a turn is equal to half of 360 degrees, and that is 180 degrees. What is the size of angle FGH? Now, notice the middle letter tells us the position of the angle we're looking for, and you can see that's this angle. So we're going to use the fact that the sum of the angles in a quadrilateral is 360 degrees. So the sum of the angles we already know is 260 degrees. So to find the missing angle, we'll subtract 260 degrees from 360 degrees, which means angle FGH is 100 degrees. Okay, let's do some new learning for this lesson. If you're asked to measure the size of this angle, how would you go about it? Well, the first thing you'll notice is this angle is a reflex angle, so it is more than 180 degrees. Now, at first, if we try to measure it like this, so if we put the cursor, the crosshair of the protractor at this point, we can only measure up to 180 degrees. So using our inside scale, which lines up with the line segment on this part of the diagram, you can see that we cannot extend up to this point here, the other line segment. So we're going to have to use a different technique. So first, we'll use our ruler and extend the line segment that we try to measure from. So we can just put a dot somewhere, all right, or we can just extend the line using a dashed line. So we know that the angle on a straight line is 180 degrees. Now, what we can do is to place our protractor in that position, making sure that this scale here, the inside scale, lines up with the line that we extended. Now, when we measure the angle between the line that we extended and the other line segments, we'll find that that is 39 degrees. So our full angle would be 180 plus 39 degrees, which is equal to 219 degrees. That is one way of measuring it. But there is another way. So when we want to measure reflex angle, here is what Dora says. Dora says, I measure the size of the acute angle to help me find the size of the reflex angle. So this is the other method that Dora is using now. I want you to think, how did this help Dora to find the size of the reflex angle? And I also want you to think about it. Could we have used it here? Well, let's see. We know that the sum of x and y, so we want to measure the angle, the reflex angle x. But Dora said that she found x by measuring y. Here is what we know. We know that the sum of the angles at a point or a full turn, which is the sum of x and y, is 360 degrees. So what Dora would have done is to measure y and then subtracted that value from 360 degrees to get x. And we could have used it here. Okay, it's now time for you to pause the video and practice what you've learned. So pause the video and answer question 1 in 3 minutes. So what you could have done is you could screenshot this, print it out so that you can have a good practice, or you may have bought the workbook from White Rose Maths so that you can practice. Okay, assuming you've paused the video and you've practiced this, here are the answers. So to measure these angles, you could have measured this angle here and then subtracted it from 360 degrees to get that angle. So you could have found, your protractor is only up to 180 degrees. So measuring here, you could have found that that is 160 degrees. So when you subtract that from 360, you will find that that is 200. And it's the same approach that we would have used all other angles. So measuring these, you could subtract. So let's just discuss each of them. So measuring these, we can subtract that from 360 to get this angle. When we measure this, we can subtract that from 360 to get this angle. Measuring this, we can subtract this angle from 360 degrees to get this angle. And then measuring this, we can subtract this angle from 360 degrees to get this angle. Same here. We measure that, we subtract this angle from 360 degrees to get the reflex angle. Pause video and answer question 2 in 1 minute. Okay, assuming you've paused the video and you've answered question 2, here is the answer. So here, Whitney is measuring this angle. She says the angle is 120 degrees. What mistake has Whitney made? Well, considering what we've learned so far, the mistake she's made is she's measured the obtuse angle, not the reflex angle. So to find the actual reflex angle, Whitney should subtract the angle that she measured, which is the obtuse angle, and then subtract it from 360 degrees, because the whole angle should be 360. So if she had measured this as 120 degrees, to find this one, she could subtract 120 degrees from 360 degrees, which will give her 240 degrees. Pause the video and answer question 3 in 2 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. So here you were given an irregular hexagon and you were asked to measure and label the interior angles. So we can use the same approach that we've learned. This one would be easy to measure. We can use our protractor. Remember what we do. We line up the crosshair of the protractor at the point here, the vertex. We make sure the zero line, either using either the inside scale or the outside scale, lines up with one of these line segments, and we measure the angles. So we know that skill from our previous lessons. This one, you simply measure that one and you subtract it from 360. You measure that angle and you subtract it from 360 degrees. You measure that angle, and these ones are straightforward. Okay? So mark your work and celebrate your success. Pause the video and answer question 4 in 1 minute. All right, assuming you've paused the video and you've answered question 4, here is the answer. So we're going to discuss this real quick. So here, Dexter says it is not possible to use a protractor to draw angles greater than 180 degrees. Dexter is incorrect. Obviously, he is. How would you discuss this with a partner about how you would measure an angle of 225 degrees using a protractor? Well, this is what we're going to look at in our very next part of the lesson. Now, what I want you to know is we know that our protractor is only half, which is 180 degrees. So how would you, or what would you add to 180 degrees to get 225 degrees? So we know 180 degrees plus an angle will be equal to 225 degrees, which is what we want. So I want you to think, how would you do this? Well, that takes us to the next part of our lesson. So to draw an angle, for example, of 263 degrees, the first thing we'll do is we'll draw a line segment. Step 1. Step 2, we'll place our protractor, the crosshair of our protractor, at one end of our line segment. Here, I have chosen to use the left end of our line segment. The next thing we'll do is we'll place a dot at the point where the protractor ends, which is that 0 mark there, or 180 degrees if we're using the inside scale. In fact, we want this line to be 180 degrees. Remember, the angle on a straight line is 180 degrees. Step 2, we'll place our protractor. Remember how we measured from our previous example. This time we're drawing. So we'll place our protractor upside down. Why? We want to be able to measure from the end of the line segments the extra angle we need to make 260 degrees. And that's what we're going to do. So we know that 180 degrees plus an angle we do not know is equal to 263 degrees, which is what we want to measure. So 263 degrees minus 180 degrees will give us the angle that we actually need. In this case, the angle is 83 degrees. Now, we'll put a mark for 83 degrees for what we actually want. So we now have the angle that we wanted to measure. So what we simply do is we take a ruler and we join that point from the end of the line segment that we drew before. So that angle is 263 degrees. You can pause the video and practice this again because it's a very important skill. Okay, here is what another method. All right, remember how we measured those reflex angles. We measured either the acute or the obtuse angles, and we subtracted those angles from 360 degrees. Maybe that could help us draw angles that are reflex. So let's try that. So Dora says, I measured an angle of 97 degrees to help me draw 263 degrees angle. How did this help Eva? So let's have a think. Well, you know that 97 degrees add 263 degrees will be equal to 360 degrees. So what helped Eva is Eva knew that she wanted to measure 263 degrees. So in fact, I like this method. If you notice, that's what we use. It was this method we used to answer most of the questions from the first part of our lesson. And I would suggest you stick to this method. So we know we want to measure 263 degrees. This is what we want. We want to draw this angle. So we need to start thinking, what's left? Okay, we know angles at a point is equal to 360 degrees. So if we subtract 263 degrees, the angle we want, we can have the angle that will be easy to draw. In this case, is 97 degrees. So if you draw 97 degrees, you know that the other part has to be 263 degrees, which you want. And you can use this approach in drawing different reflex angles. Okay, if you're asked to make an accurate drawing of the diagram to the right, how would you do this? Well, you can clearly see that the diagram is not drawn accurately. So step one, we know that to be able to measure this, when we draw it initially, it would look like this. So this is clearly not 2 centimeters because we want this line to be 6 centimeters and that line to be 2 centimeters. Your protractor, which is the radius of your protractor, is usually about 5 centimeters. So you would need to have to extend the line when you have drawn your angle, and that is the method we'll use. So for this one, we can simply do 360 degrees minus 345 degrees to give us the angle we actually want. The angle that we can draw so that we can create, we do this so that we can create the angle that we want, so that when we draw that angle, that will create the 345 degrees for us. So if we do our subtraction, that will be 5 and that will be 1. Okay, so if we draw 15 degrees, we know this is easy to draw because we can use our protractor to do this real quick. So we draw a line segment. We can make sure that line segment is 6 centimeters. We place the crosshair of our protractor here, making sure that lines up with 0. And then we measure 15 degrees and we place a mark. We connect the end of our line to that mark that we have placed from the protractor. And then we know that that has to be 345 degrees. Now, what we need to do is we need to place a ruler, because we need that line to be 2 centimeters. We need to place a ruler at that point and mark 2 centimeters, which is what we've been asked to do. And then we use a rubber to rub the other part off. Okay? And that answers the question. It's now time for you to pause the video and answer the other parts of the question for you to practice. So pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered question 5, here is what you would have. So for this one, I'll just discuss what you need to do. So step 1, you're asked to draw angles. So you draw a line segment for each of them. Simple line segment, could be horizontal, it could be vertical. Step 1 for this one, you will do 360 degrees minus 285 degrees. You measure this angle. So this will be 360 minus 285. So that will be, let's bring this further down. Let's rub this off. Let's bring the line segments further down. All right. So when we do our carry, that will be 5. We do our carry again. That will be 7. Okay. All right. Because 15, that will be 15 minus 8, which is 7. So if we draw 75 degrees, which will look something about like that, we know that the other side should be 285 degrees. So using your protractor, if you do this calculation, you measure 75, that would create the actual angle that you wanted to measure. And this the same approach you would use here. So you do 360 degrees minus 241 degrees. You measure the actual angle of this calculation. All right. And then when you finish, the other side is the angle you actually want, which is 241 degrees. You do the same here. So you do 360 degrees minus 354 degrees. We know that this is going to be 6 degrees. It's going to be a very small angle, right? Very small. So if this is 6 degrees, you know that this other side has to be 354 degrees. Okay? So that's the approach you use to answer these questions. All right, here is this one. Pause the video and answer question 6 in 3 minutes. Assuming you've paused the video and you've answered question 6, let's discuss what you get, the result. So for this one, you were asked, make an accurate drawing of the arrowhead, which is the length of, and then you've been asked, what is the length of the side marked A? Now, to make an accurate drawing, the first thing you're going to do is you have to draw a line segment. You make sure this line segment is 2 centimeters. Next, you measure 40 degrees on this side, and then you extend it as long as you want. Extend it as long as you want. Don't really bother about the length. All right? Then you measure 215 degrees on this side. So from this line segment, the end of this line segment, you measure 215 degrees from this line segment all the way to this point here. Okay? Or you can do 360 degrees minus 215 degrees to measure the angle from here to here. And then you extend the line all the way. All right? And make sure that line is 2 centimeters. Then you can use your protractor to check that you can measure 40 degrees from the end of this line segment. And then you connect that to the other line and draw it as long as you want. When you finish this, you will form the arrowhead, and then you can measure the length of that line, which will be 3.5 centimeters. So this will be a good point for you to practice drawing this arrowhead. It's a really good practice for you to do. Pause the video and answer question 7 in 3 minutes. Assuming you've paused the video and you've answered question 7, here are the answers. Let's discuss them. Here you were asked, an aircraft takes off from the runway shown in the diagram. It flies for 10 miles in the direction shown by the arrow. It then turns clockwise through an angle of 80 degrees. So it turns clockwise through an angle of 80 degrees. So it flies in this direction for 6 more miles. And then it then turns anti-clockwise through 260 degrees and flies for 12 miles. Draw a diagram to show the path of the aircraft. Now, to start answering this question, what you need to think is the aircraft takes off from the runway shown in the diagram. So it's taking off. It flies for 10 miles in the direction shown by the arrow. Now, what we need to do is we've been asked to use this scale. 1 centimeter is equal to 2 miles. So if 1 centimeter is equal to 2 miles, 10 miles is 5 lots more than 2 miles, okay, times 5. So we need 5 centimeter to be equivalent to that 10 miles. So this line should be 5 centimeters. So from the aircraft to that point, we measure 5 centimeter. That represents 10 miles. Then we do our knot line at the end of the 5 centimeter. We have our knot line. Okay, from that point, we're going to measure. Okay, next, it turns clockwise through an angle of 80 degrees. So from the end of this line, segment, we need to measure clockwise 80 degrees. So we measure 80 degrees. So it should be about that, not up to 90 degrees. So 90 degrees should be like that. So we measure 80 degrees. All right. And then remember, for that 80 degrees, we need to measure this line because it flies in this direction for 6 more miles. So after measuring 80 degrees, we need to use, because 6 more miles, okay, 6 more miles is 3 lots more than 2 miles. So it means we need 3 centimeters. So the length of this line, so remember here we used 5 centimeter. Here we're going to use 3 centimeter. So again, we're going to put our knot line there. So at the end of that line, we need to measure anti-clockwise 260 degrees. So if you remember how we measure 260 degrees is using the method we knew before. This line here, so from the end of that line, from the end of this line, if we measure 180 degrees anti-clockwise, we would be here. And then the extra 40 degrees, 180, yeah, 180 plus another 80, the extra 80 degrees would extend somewhere here like this. Okay, so this would be from the end of this line all the way. That will give us our 260 degrees. Now, it flies 12 miles in this direction. So 12 miles is 6 lots more than 2 miles. So we need 6 centimeter to represent this. So here we'll draw 6 centimeter for this line. All right. And that should represent the flight path of this aircraft. And that brings us to the end of our lesson. Really well done for sticking around, for learning how to measure and draw angles between 180 degrees and 360 degrees, otherwise our reflex angles, otherwise called our reflex angles. Well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself, and bye-bye.